Welcome back. In the last video, we learned the terms AI, machine learning, and neural network. And we just used a logic gate as an example to show how machine learning works and how we can improve the accuracy by enlarging the data set. In this video, we will dive into the subfield neural network. In some ways, a neural network is little more than several logistic regressions models stacked together. Therefore, before we dive into the neural network, we will start off with a logistic regressions. Let's get started. As mentioned, neural networks are somewhat related to logistic regressions. Basically, we can think of logistic regressions as a one-layers neuron, and these one-layers neural network, and these neural networks classifies the data categorically. That is CO1 or CO12 or CO123, something like that. So there are a few steps that we can perform a logistic regressions. Similar to many other machine learning algorithms, we need to initialize the parameters. And in logistic regressions, there are two parameters we need to initialize, which are the weights, W, and the other one is the bias, B. Once we initialize these parameters, we will create a loop to repeat the following three main processes. In the first step, we work on a forward propagations, and then we calculate the loss. And then in the second step, we work on the back propagations to calculate the gradients based on the loss. And once we have the gradients, we will use them to update the parameters. And we continue within this loop, and we continue to repeat these three processes until a certain criteria is reached, and that allow us to break the loop. Let's go into the details for each of the steps. To calculate the loss, there are four key steps in the forward propagations. Logistic regressions takes an input and calculates the weighted sum. And here you can see that these two parameters, that is weight and the bias, that actually takes the input from x1 and x2 as an example, w1 times x1 and w2 times x2, and then we pass the bias and then we sum it up all together. Therefore, we take the input and calculate the weighted sum. And once we have these weighted sums, and this weighted sum is passed on to a activation functions, and in logistic regressions, that is a sigmoid function. A sigmoid function is a function which, let me show it up larger. A logistic function is, a sigmoid function is a function which outputs 1 when the values of x is large. You can see this is somewhat here around 5 to 10. The values becomes plateau, and then and outputs 0 for a very small values of x. So the activation functions, the sigmoid activation functions, just try to output 1 when the value of x is large, and output 0 when the output is when the input is very small. And therefore, after going through the first two steps, we calculate the weighted sum, and then we go through the activation functions. The value will be, the output value will be in a range between 0 and 1, which is y hat shown here. Somehow, probability is also between 0 and 1, and as a result, these outputs can also be interpreted as a probability. So the final step is calculates the loss. What we're going to do here is actually to assign a loss as our objective functions, so that we can actually optimize these objective functions. And on top of this, you can see here are the mathematical equations behind, but I'm not going through them in details. The rationale behind this loss function is that instead of minimize the error, we maximize the likelihood. This seems like a logical place to start, maximizing the probability that our model parameters are correct. And then that means we would like to maximize the likelihood, and then which is equivalent to maximize the log likelihood. And it's also equivalent to minimize the negative log likelihoods. And this is because log function is a monotonically increasing function. So finally, we have these minimizations objective functions that we want to minimize through the back propagations. Very quick recap. In the first step, in the forward propagations, we take the input and calculate the weighted sum, and then we pass this weighted sum through the sigmoid functions and returns an output of probability between 0 and 1. And with that value, we calculate the loss. So once we go through the forward propagations, we can start our process in backward propagations. Since the loss functions that we just mentioned only represent one training sample, in that case, we need to sum up all the losses for the training samples and take the FH of it. And the result is called cost functions. And by taking the derivatives of to these cost functions with respect to the two parameters, that is the weight and also the bias, we can calculate the gradients. And then these gradients can be used in the next step. And finally, we can update our parameters. Apart from gradient descent, that is the djdw, djdb, we just calculate, we can also assign a learning rate to it. And that means by multiplying these learning rates, this magnitude will determine the amount that we move in gradient descent. In other words, these magnitudes, these learning rates, will determine how much we update our weight parameters and also bias parameters. And these hyperparameters determines how far along the error surface we travel on each iteration, each epoch. The bigger values means we go further, which means our rates might converge to the final solutions faster. But it also means that we may overshoot that solutions. A higher learning rate means that we should move the W and B more each step. The change we make in our parameter is the learning rates times the gradients. So in that case, we need to carefully set these learning rates hyperparameters when we are working out the logistic regressions. Very quick summary on which we have just gone through. In the first step, we first of all we need to set up a loop, that is the epoch. In the first step, we work on the forward propagations, and then we calculate the loss. And then in the second step, we work on the backward propagations to calculate the gradient based on that loss. And once we have the gradient, we will use them to update the parameters. And we continue to repeat these three processes until a certain threshold, a certain criteria is met. And that allows us to break this loop. That means we put everything inside a loop, and we can, and these loops is going to help us to continue to improve the rates and bias. Here we need to decide how many epoch or iterations or steps that we want to update our parameters. The number of epoch is another hyperparameters. There are many ways to determine when to stop the gradient descent process. We will mention some of them later in these videos. We call things like learning rate and epoch, that is the hyperparameters. And these are the parameters that are not part of the model itself, but can still be used to improve our results. This is a very quick introduction of logistic regressions. In the next video, I will show you how logistic regressions relates to neural network. See you in the next video. Bye-bye.